All right. So,
Let me see it.
What did you do?
guys,
You ain't fixing it.
enough. Fine, for now. Okay. All right. So, our whole entire next unit and the unit after are going to be on quadratic functions. Okay. This unit, we're going to focus more on key features and factoring. The next unit, we're going to focus on solving because there's several different ways to solve them. So we will do all of that in the next unit. So the first thing we need to do is talk about all the key features that you can pull from a picture of a quadratic. First thing, domain. Y'all should have done domain and range with linear equations. Does anybody remember what the domain is? Your x values, good. Your domain is how far is the graph going to travel to the left and how far is the graph going to travel to the right. Okay, so your domain, if you open up this flap, okay, open up this flap. This is the set of all x values.
Is that a set?
Okay, set of all.
This is, I thought set did like the 8 and 5.
Your range is your set of all your y values.
I thought like I'm saying like I thought the set meant
It's like x,
the
y.
XY value. That's what I was taught.
No, that's a coordinate.
No, I meant like they call. I know it's coordinate. Like they call it.
Okay. Set of all x values. So, if you look at this graph, okay, if you look at this graph, what's happening on the left-hand side? What's my graph going to continue to do on this left-hand side? It's going to keep going. It's going to keep going to the left. It's never going to stop. That arrow means it's never going to stop. So, it's heading in the left direction, which is negative, and it's going to keep going. So we call that negative infinity. Okay? So your domain is going to keep going to the left and keep going. So that means it's going to continue, which means it's infinity. It doesn't have a stopping point. Okay? Anytime your domain has anything to do with infinity, it's always a round parenthesis. Okay? It's always the curved one. I'm going to talk to you about square brackets too today. Okay? So it's always the curved one when you're dealing with infinity.
Infinity looks like the 8 is turned forward.
Yes, sir. Okay. What's happening on the right-hand side? It's increasing. Is it ever going to stop? No. So that's also infinity. But this time, it's positive because we're going in the positive direction. So, I will tell you this. Anytime they ask for the domain of a quadratic, it's always negative infinity to positive. No matter what. Your domain for a quadratic will never, ever, ever change. Ever? Negative infinity to positive infinity. It doesn't change.
Always the middle.
Yep. Your range is going to change. Okay. So if domain is the set of all the x values, on the other side, your range is the set of all your y values. That's your set of all your y values. Okay. So again, if I go back to this graph, the left-hand side of your range should always be how far it goes down. How far does my graph go down? -8. There is a stopping point here. So it only goes down as far as -8. -8 is included. It is a point on the graph. So in order to denote that, we need to put a square bracket on the left side of -8. That means that it's included. If you would have put a rounded bracket, that would have meant there was a hole there. and that point was not included. Okay, so if it's a solid line where it hits, it's always a square bracket if it's a number. Okay.
What's the easiest way to remember that?
So if you would have done this, your graph would have looked like this, where this point wasn't included. So you remember, like, okay, hold up. Let's go back to, if I had x is greater than 7, and you graphed that on a number line, you would have went to 7. 7 wasn't included, right? Because it's not equal to, it's greater than. So that meant this was an open circle shaded to the right. But if I change it and make it greater than or equal to 7,
Okay.
it includes it, so it makes it a closed circle shaded to the right. Okay? So that's the same idea here. If I do this with the rounded bracket, it's like it's just greater than. So it's an open circle and it's not included. So your graph would look like this. That square bracket says that it is, and it's a solid point on the graph. Does that make a little bit more sense?
Just like, you know, a drop a bit, or like a rain drop.
Yes.
Let's put it this way. The only time you're going to deal with the parentheses right now in this unit is if it's infinity. Anytime you have a number, it's going to be a square bracket. So just keep that in mind right now. Okay. All right. So again, go back to the graph. The other side of my y values should be, how far does this graph go up? Infinity. It's never going to stop going up. So my set of all y values go from -8 to positive infinity, because my graph's going to never, ever stop going up. It stops on the way down, but it does not stop going up.
So it's called what? So it's a square and?
I don't understand.
Anytime it's after the infinity, it is a rounded bracket.
I still don't get it.
How does what?
How
Guys, I cannot hear the questions because you won't stop talking. Please stop talking.
is it positive?
Look at your graph. What's happening on my ends?
It's never stopped.
It's never stopping going up. So it's going to continue to just, your graph's just going to keep going. It's going to get wider and wider and wider, and it's just going to keep going up and out to the sides.
It's not gonna touch my brain.
Okay. So again, domain never changes. Negative infinity to positive infinity. Because your graph's either going to go up like this, or it's going to turn around, it's going to go down like this. Okay, that's the only way it's going to go. It doesn't go sideways. It's up or down. It's happy face, frowny face. Okay.
I
Yes.
think I remember learning these.
Is it possible to what? Those are square roots, which we're going to do
Except for
next.
this part.
After quadratic. It's,
Like those. Okay, cool.
okay. All right. Your next very, very important word. Your next very, very important word is vertex. Okay? You're going to see this over and over and over again.
Line
Okay.
of symmetry.
It is not your line of symmetry. That is your axis of symmetry. You've got something though. Okay? Your vertex. Okay? You're going to have two types. You're going to have a minimum, which is the low point of your graph, or a maximum. Okay? So, your vertex, they call this your turning point. This is your turning point. Okay? If you have an upward facing parabola, this is your vertex. And this is a minimum. Okay? It's the lowest point of your graph. And they call this your turning point. Because remember, you read a graph like you read a book from left to right. Okay? So if you start at the left-hand side, your graph goes down, 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 down. It hits that vertex, and then all of a sudden it starts to go up, 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 up. So that's why they call it your turning point. Okay. Again, I told you could have upward facing U's. We can also have a downward facing U. Yes. So this is your vertex still, but now instead of having a minimum, we've got a mountain. So we have a maximum. Okay. So instead of having a low point, I now have a high point. If it's a valley, we have a low point, we have a minimum. If it's a mountain, we have a high point, we have a maximum.
I remember this.
Okay. So, if you go to the graph, where is my vertex? -2, -8. This is your vertex. Mark it. Vertex. If that's my vertex, what do I have here? Is this a max or a min? This is a min.
Most of them are mins.
Most of them are. A lot of the stuff that we deal with is a. So you have seen this before?
Yeah, Miss Hopkins.
Good.
That's when I was in Jack.
Happy, happy, joy, joy.
She said this when I was in jail.
Yeah, that's what I was in Jack.
You know what? A++ for learning something.
No, I was a model student down there. Even Mr. Wilkes said that.
You can't be a model student in Jackie.
Because I was.
How you a model student?
Because I helped everybody. I was good.
Oh, model
Other than what I
You was a model student.
All right. Back to math. Back to math. All right. Muhammad, here, we're looking at the axis of symmetry. What did you say that was, Muhammad?
I said line of symmetry.
It's your line of symmetry. Okay, your axis of symmetry is an invisible line that cuts your graph into 2 equal sections. It's basically your line of reflection. And what did you say, Elijah? It's on your vertex. Okay, your axis of symmetry is an invisible line that cuts your graph into 2 equal sections. Okay, this is always a vertical line. Okay, so if it's always a vertical line, that means it should always be x equals. Because remember, a vertical line goes through the x-axis. A vertical line goes through your x-axis. Elijah also said, too, that it goes through your vertex. Okay? So your axis of symmetry always goes through your vertex. So in this instance, let me grab a highlighter here because it'll show up better. Okay? In this instance, your axis of symmetry is this line right here. Okay. That's your axis of symmetry. Axis of symmetry. Okay, and it's x equals. What number does it go through on the x-axis? -2. Okay, so your axis of symmetry, the number that's in your equation should always match the x part of your vertex. If it does not, there's something wrong. Okay.
What if you have one of those sides? Like this.
You won't have that in the section. That's squares. That's the opposite of quadratic. It's the inverse. All right. Has everybody got all that?
No. Yeah.
No, yeah. Yes, x equals -2.
Anyone is.
Okay. We've got two more very important terms here. The next one is roots, or sometimes they call them zeros. Okay. Roots, or sometimes they call them zeros. There's one other name for this. Solutions. Oh, I lied. There's two other names. Ooh, she pulled one out on me. Solutions is another one. There we go. I forgot about that one. I was going for another one. Go, Allison. Go, Allison. Okay. This one you might actually know, though. Ready? X intercept.
Oh.
Oh.
Okay? All four of those words mean the same thing. If you're trying to find a solution, you want the x-intercept. If you're trying to find a root, you want the x-intercept. If you're trying to find a zero, you want the x-intercept. Okay? So, an x-intercept is what?
When y equals 0.
Where you cross the x-axis.
Why don't they just call it x-intercept?
Isn't it when y equals 0?
Yes, when y equals 0. So where the graph crosses the x-axis, or when y equals 0.
So wouldn't it be -6 and -2?
Good.
You see, Mr. Harrison said is when y equals 0, and I was like, what is that?
Right. I used to get so confused. I hated his
Because if it's on the x-axis, what's your y
But
value?
he's the favorite
0.
teacher I've ever seen in my life.
I hated his teachers.
I hated how to
teach.
I never liked him.
Just because you
Struggle.
struggle with learning with him does not mean he does not know how to teach. You have a hard time grasping concepts.
saying I have learning deficiency.
No, I'm not saying,
No, Mr.
don't put words into my mouth like that. No, but even when you go to college, you will notice there are professors that you sit in their class and you're like, huh? But if you had somebody else, you'd be like, oh.
No, but he called me stupid.
He called Rebecca stupid.
I was like, no, I'm going. So
I don't know any of that. That's none of my business. That's none of my business. That's above my pay grade. All right. So, where does this graph, and somebody's already said it, cross the x-axis?
-6 and -2.
Not
I mean positive.
-6 and +2.
That might be punchy.
X equals -6 and x equals +2. These are your x-intercepts. Okay.
Why does X equal everything and Y doesn't?
That's the next flap. I got you, Mo. That's the next flap.
Okay.
My last flap is the y-intercept. If x is where it crosses the x-axis, your y-intercept is
Where
it crosses the y-axis. Right. So, where the graph crosses the y-axis. Guys, enough. Where it crosses the y-axis, or when x equals 0. Because remember, if we're on the y-axis, your x has no value. It's a value of 0. No. Okay. So again, if I go back to this graph, where does my graph cross the y-axis?
It doesn't.
It's kind of like a -5.5. Okay. It's kind of like right here. Okay. It's kind of like right here. So This is y equals negative, let's go with 5.5 because it's kind of not on the,
Wait, what do you mean? Why is it over there?
It's in between.
it's on your y axis. That pink line that I drew was your axis of symmetry. That's not your y axis.
Oh,
Don't use that. Don't use that as your y axis. Don't let that confuse you. Okay? That pink line is not your y axis. That's your axis of symmetry. Your y axis is this one. Okay? So please be very careful. That's why you guys were like, wait, what?
Because the line is so light, you can really see.
Okay. Always look for the arrows because they'll always have arrows at the end of the y-axis and the x-axis. Okay. So that will kind of help.
somebody stole my.
You need a pencil.
I don't need a pencil. I need my glue then.
I thought you said somebody stole your pencil.
Somebody stole my glue.
Right, somebody stole my
Glue right there. That ain't glue. How?
Oh, the
Tell me how they glue sitting right here,
It's tucked and rolled.
and it went all the way back there.
All right. This one glues is on page 36, my friends. 36.
The floor stole.
Somebody stole mine.
You saw it, what?
36.
36.
Oh.
I nearly had it.
That's right, you heard that.
Okay. Guys, just because I tell you to glue something in does not mean stop, have conversation. Page you should have. I need you to cut them out in strips of 3. Okay? You do not need the equations with the second graph, so you can cut off the equations if you would like. If you want to keep them, I'm okay with that as well. Okay? So, strips of 3. So like this. Make sure you leave 1, 2, 3, 4, 5, 6 lines in between this one before you glue in the second strip of grass.
You have to leave the ABC on.
You do not. Okay.
I hate pictures that do that. And then the scissors won't cut.
Okay, so kind of like halfway down the page, you can put in the second strip and glue them in like this.
Oh, that's ugly. Can I get another paper?
Can't even cut straight long.
Can't cut a straight line.
No,
This is so ugly.
I can draw a straight line. I can draw one. I can. I can. I just can't.
I'm so glad you're back, Rebecca. We missed you.
We did not.
Huh?
Because I thought.
No, we did not. Do not lie to me.
Yes, we did.
You got a lot of me. I know.
Sissy told me you had stress throat.
Annette gave it to me.
Well, what'd she do that for?
30 people trying to do it.
She gonna pull.
My point.
Right, your point.
She comes home with it like every 2 weeks. Oh my God.
Damn.
Oh.
Would she be?
No, I don't like that. That's not really good. You're supposed to take
Are they the same graph?
No, they're all different. They're all different. So what we're gonna do with these, and I'm just gonna tell you what we're gonna do while
you
you're
cut
finished
these
typing
out?
them out and gluing them in. What? The equations at the top? Yeah, you don't need them.
Did you put?
Yes. I cut mine off. Okay. So, no, you do not need the equations at the top. You just need the pictures. Okay. We're not doing anything with equations today. It's all from a picture. Justin, did y'all win yesterday?
No.
I see this.
Look, we don't need to talk about that.
Right, that was not their
We can
birthday.
go on about math class.
Jeffrey texted me when he got home. I was
Here, what
like,
Jeffrey did.
I was like, how was the game? He was like, I don't want to talk about it. Let's talk about you. I still love you.
You just gonna smack Salisbury tonight.
I
That's all.
was glad like I started.
All right.
Because Jeffrey was like, I don't want to talk about it. Let's talk about you.
It looked like it was.
Okay. So what we're going to do with these graphs is we're going to identify all of those key features we just talked about. Okay. So if you look at graph A, the first thing we need to talk about is the domain. How far does this graph stretch to the left? And how far does it stretch to the right? So to the left, negative infinity. It's going to keep going. And to the right, positive infinity. Does your domain ever change? No. Okay. Your range. How low does it go? How high does it go? So how low do we go? To -8. We go low to -8. If I go any lower than that, I ain't getting back up. So.
Girl, I know what you mean.
Okay. So we go low to -8. How high do we go? Infinity. It's going to keep going up. So it goes from -8 to positive infinity. Okay. Your vertex. The first thing I want you to do is tell me, is it a minimum or a maximum? It is a min. My vertex is a min. Okay. What is the coordinate of my vertex?
Wait.
3, -8. Good. It should be right here. So that is 3, -8. Okay. Huh? Should be a minimum.
Why do you put AOFS instead of AOS?
Right.
She literally put AOS.
AOS.
No, back to front. This needs to go here. These need to go here. You're never going to have enough room if you do that. Yeah, it needs to be fixed.
Looks like Brandon needs a new notebook.
Okay. Axis of symmetry. Remember, that's your vertical line that drops through your vertex. So that is this line right here. That's x equals 3. Please don't ever just give me 3. It needs to be a line, so you must have that x equals there. Okay. Your x-intercepts.
1 and 5.
1 and 5. X equals 1. X equals 5.
What's MM mean?
M-I-N. Minimum. Sorry, that's an I. So we're at 1 and 5. Your y-intercept. Probably about 5. You can't really see it.
It's probably 6.
Okay. If you can't see it, I'm okay if you write not applicable or none.
5.5.
Okay.
6.
So if you want to just put not applicable here because we can't really see where it crosses, they've cut off that section, but we do know it will cross it at some point. Okay. And yes, you're right. It's probably about 5, 5.5, possibly 6. Okay, from the way it looks.
Is that what FA means?
Not applicable?
Really?
Yeah.
You might know that.
I learned that 2 years ago.
Not available, not applicable.
Not available.
Okay.
Really not available.
All right. Part B. Part B. Part B. Again,
Again?
domain. How far does my graph go to the left and to the right?
Negative.
Negative to positive infinity.
But it's not on the negative side.
But your domain never changes.
What do you mean it's not on the negative
No.
side? Are you talking because the graph's not on the negative side?
Yes.
But still, even then, if I've got this graph mill, it's gonna keep going and going and going and going and going. She's not paying attention, so I'm. It's going to keep going. So even though it's not on the negative side yet, it's gonna continue and move over there. Your graph of a quadratic either goes up, 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 it never stops, or it goes and I can't go any lower than that.
So eventually
Yes. Okay. It keeps going. That's why they put the arrows on there to show that it keeps going. They can't picture it all, but they'll put the arrows there to show you that it keeps going. Okay? Your range. Take a look at your graph. How low does my graph go?
Negative.
Negative infinity.
Oh.
It's going down this time. Whoops. I really screwed up that one.
What is that?
That's my really screwed up infinity sign because I went to write an 8 instead of the sideways 8. Okay. How high does my graph go? 0. So it goes to 0.
I'm confused.
You did 2 different weird brackets.
We've already talked about that.
I thought you were supposed
If it's a number, it's always the square bracket to show that it's included as an answer. Infinity does not stop, so it's a rounded bracket. Okay. Where's my vertex on this one? And is it a min or a max?
It's good math.
This one's a maximum. And where is my vertex? 2, 0. I then have an axis of symmetry.
X equals 2.
X equals 2. Again, your axis of symmetry should always match the x part of your vertex. Okay? X intercepts.
2.
Just at 2. This one only has 1, and it's just at 2. And finally, y intercepts.
Negative 4.
-4.
Now for C.
Now for C. This is pretty easy though, right? It's not too bad. You're tired.
I don't understand. Yes, I could not go to sleep.
Okay. Again. Domain. To the left.
Negative infinity.
I was hoping somebody was going to answer me before I hit the wall.
Oh, I should
To the right.
That's it.
Oh, you're not nice. You're not nice. You're not nice. You're not nice.
Infinity, positive.
Thank you.
She was almost there. I was just saying as soon as she hit the wall.
I couldn't.
Y'all are determined to like let me hit a wall and
I
not
was
just
gonna
go
say
out.
it.
Just be laying on the floor.
I was gonna say as soon as you let me
You're gonna make me have brain damage.
infinity. Wait, I got it. Infinity.
Huh?
Say it slower.
I didn't have a
You get some concussions and stuff, you could end up with some brain damage. Okay. My graph. Hello, can we go? Hello, can we go? I'm not saying
I can go
until
lower
you
than
fall.
that.
I'm so glad you can, because
I
if Smith's
can.
old, she won't get back up. Old.
You're not old.
Where are you?
Where are you old?
So, my graph goes as low as negative infinity. I'd fall through the floor if I kept going. Okay? How high does my graph go?
It goes
To positive 4. Good.
How high does it go?
Okay. Where's my vertex?
Your vertex is max.
It's a max.
1 vertex.
Negative
-1
one.
and
4 and -1. I mean, negative, yeah, -1 and 4.
Negative 1, positive 4.
And this graph is running by 2s, right?
No, it just marks it every other.
Right. Which one am I first? Is he alive back there?
Yeah.
it's
Are you alive?
No,
Please
it's
don't
not.
die on me. Please don't. Okay.
I don't know who that
Where is
I do.
your axis of symmetry? X equals
-2.5 and 0.5.
axis of symmetry. It must go through your
Negative
vertex.
one.
Negative 1.
I'm on the next one.
wait, what?
Your axis of symmetry is the vertical line that cuts your graph in half.
I'm confused.
So it
Wait,
goes,
stop.
The vertex, how it goes to the point, it goes up.
your axis
No,
of
the axis
symmetry
of
goes
symmetry.
through your vertex. It's the vertical
Oh.
line that if I would cut your graph in half, it's the same on either side.
Alright, now it's -2.5 and 0.5.
Good.
I'm right.
Your x-intercepts are at -2.5 and 0.5. They don't hit exactly on the line. That's okay. Okay? If
Plus-
it does not, give it your best guess.
Plus 0.5.
Oh, that's my and sign. Sorry. That's my and sign. Okay.
And then 2.
And then finally, it crosses your y at 2. Okay. So,
That's some tissue.
there's tissues over there. Here's the deal. I have an around the room that I want you to do. So we're gonna stop there, which means, listen, the last 3 in your notebook is your homework for this.
Oh, that's easy.
No worksheet tonight, those. That's it.
I love you.
Okay? So you can close up your notebooks for now. We're gonna do an around the room activity.